Welcome back everyone. Today we are going to make a few high pressure ampoules from these here. We first turned on the torch because we need a really hot flame. We are using borosilicate glass tubes. Firstly, we will just seal one side of the glass tube. We do this because we want to store compound in them and we need to get at least one side sealed to make it easy to fill in any liquid or gas or whatever. If you look closely at the flame, you can see that it's yellow. This is because there are sodium ions in this borosilicate glass. When sodium ions are ionized, they give off this really nice reddish or orange glow. Once the end of the tube was sealed, we place it onto a piece of copper wire in order to allow it to cool down slowly. Ready-made ampoules that were already cold were placed onto the table because they will not melt the plastic anymore. With an oxyacetylene torch and the hot glass you have to be really careful. This stuff is so hot that when you burn yourself, you will not notice it. I can tell you from experience that burns with extremely hot materials are something that you don't want to experience. For this reason, keep your hands away from the flame and make sure not to touch your hands with the red hot glowing glass. 28 of these one-side sealed glass tubes were made in total. This is what they looked like once they were finished. We want to be able to seal them quickly once the substance is in there, therefore we are going to stretch out the neck. The oxyacetylene torch was turned back on. It's amazing that an oxygen-acetylene mixture can get extremely hot. Actually, it can get hot up to 3200 degrees Celsius. With this you could, for example, melt gold, copper and iron. However, tungsten with a melting point of 3422 degrees will not melt. When the neck of the ampoule has been stretched out, it will make it really easy to seal it later on, when for example we have liquefied chlorine, liquefied ammonia or whatever in there. With a thinner neck, not as much heat to melt the ampoule is needed. This also means that not enough heat will be transferred to the substance we want to store in there because we don't want it to boil. Liquefied chlorine, ammonia and sulfur dioxide have already been covered. If you have any idea what gases we should liquefy and store next, feel free to write it down in the comments and I'll try what I can do. And here you have it, we made 28 of these high pressure ampoules in total. All of these will be used in the future to store some gases you have probably never seen in liquid form before, and just to have those gases on display. If you like this video, make sure to drop me one of these and consider subscribing to my channel for more awesome chemistry content in the future. Wish all of you a nice day, until next time, bye.